Let's read it. Part A is a short calculus puzzle. G is the derivative of 1 over x squared plus 1, and we integrate 3g plus 1. Part B uses a sideways graph, x equals f of y, with a shaded area split across 3 bumps. Here's everything we're given. That derivative fact, the total shaded area of 9 over 2, and 2 of the bumps each measuring 3 over 2. And here's what we must find. The integral in Part A, then 2 values from the graph. So here's what we have and what we need. We'll knock out Part A first, then bring up the graph for Part B. Part A, we're told g is the derivative of 1 over x squared plus 1. The key idea is that integrating just undoes differentiating. Integrate a derivative, and you get the original function back, plus c. So the integral of g is exactly 1 over x squared plus 1, plus a constant. Now the question. Split it up, 3 times the integral of g plus the integral of 1. We already know the integral of g, so swap it in, and the integral of 1 is just x. Tidy it up, and Part A is done. 3 over x squared plus 1 plus x plus c. Now Part B. Here's diagram 8. Notice the curve is written x equals f of y, so we read it sideways. At each height y, f gives the horizontal distance from the y-axis. The shaded region is what's trapped between the curve and the y-axis. It has 3 bumps, one from O to H, one from H to K, and one from K to M. Here's the whole trick of Part B. Where the curve lies to the right of the axis, x is positive, so its integral is positive. Where it swings to the left, x is negative, so that integral comes out negative. Let's park the graph beside us and work through it. We're told these 2 right-hand bumps each have area 3 over 2. Part B, first value. We want the signed area from 0 up to k. All 3 bumps together make the total area, 9 over 2. 2 of them are 3 over 2 each, so the middle bump must also be 3 over 2. But the middle bump sits to the left of the axis, so x is negative there. Its integral is minus 3 over 2, even though its area is positive. Now we use the rule that an integral splits at any in-between point. From 0 to k is 0 to h plus h to k. They cancel, so the value is 0. Part B, second value. 2 pieces added together. On this curve x equals f of y, so the first piece is just the signed area from h to k, which we already found is minus 3 over 2. The second piece pulls the 5 over 4 outside the integral. 5 over 4 times the top bump, 3 over 2, which is 15 over 8. Add them with a common denominator, and the answer is 3 over 8. Final answers. Part A is 3 over x squared plus 1 plus x plus c. Part B1 is 0 because the 2 bumps cancel, and Part B2 is 3 over 8.